Today, we are going to discuss some electrical and electronic devices that are used in X-ray machine. But we are going to limit our discussion to what the device is. Its application to the X-ray machine will be discussed in our succeeding topic, X-ray circuitry. The first electrical device is a transformer. Transformer is a device that is used to change the magnitude of electric current and potential into higher and lower values. But we most commonly associate transformer to a device that changes the potential or the voltage, such as when an electrical device needs 110 volts, but what we get from the socket is 220 volts. Then we will need a transformer, such as this one, to change the voltage from 220 volts to 110 volts, so it will be compatible to our device. Transformers also come in different forms and sizes with different capacities. We have bigger ones such that it can power a whole city, and we have smaller ones for specific appliances. And this is the symbol for transformer. Transformer applies the principle of mutual induction, which we have discussed in our previous topic, and it will operate only with a changing electric current. Remember that in mutual induction, it is the changing direction of electrons that causes the changing magnetic field, and the changing magnetic field causes a current to be induced in another circuit. The transformer is composed of two coils of wire wrapped around in an iron core. The first coil of wire serves as the primary coil, carrying the primary circuit, and the second coil of wire is the secondary coil, carrying the induced current or the secondary circuit. The secondary current has a different magnitude and voltage, and that change is mainly dependent on the difference between the number of turns between the two coils of wire. This change is outlined in the transformer law. The transformer law states that the change in the voltage is directly proportional to the ratio of the number of turns in the secondary coil to the number of turns in the primary coil. The equation is given this way: Vs over Vp is equal to Ns over Np. Vs stands for voltage in secondary coil, while Vp stands for voltage in the primary coil. Ns stands for the number of turns on the secondary coil, while Np stands for the number of turns in the primary coil. This equation means that if the number of turns on the secondary coil increases, the voltage will also increase. But the change in current is different. The change in current across the transformer is in the opposite direction from the voltage change, but in the same proportion. This means that the change in current is inversely proportional to the number of turns. Current decreases with increasing number of turns. This is given in the following formula: Is over Ip is equal to Np over Ns, where Is is the current flowing in the secondary coil and Ip the current flowing in the primary coil. Therefore, we can categorize transformers according to its voltage output. The first one is the step-up transformer, which is a transformer that increases the voltage. It has a turns ratio greater than 1, which means that there are more number of turns on the secondary coil than on the primary coil, increasing the voltage but decreasing the current. The other type is the step-down transformer, which is a transformer that decreases voltage. It has a turns ratio lower than 1, which means that there are fewer number of turns on the secondary coil than on the primary coil. This decreases the voltage but increases the current. Another type of transformer is the autotransformer. Autotransformer is made from a single primary winding wrapped around a laminated magnetic core, and it operates on the principle of self-induction. This kind of transformer changes the voltage to the secondary side by changing the position of the top. In this example, the the secondary circuit will have a lower voltage because the top includes fewer number of turns than the primary top, but the current will be higher. The next device is the capacitor. A capacitor is a device that stores electric charges, producing a potential difference across its plates, much like a small rechargeable battery. It also comes in different shapes and sizes. Most electronic products uses capacitors, such as in timing circuitry, tuning dial of a radio, the flash of a camera. In medical X-ray, we also have capacitor discharge portable equipment. Capacitor is also used to smooth the voltage ripple. And this is the symbol for capacitor. A capacitor consists of two or more parallel conductive plates that are electrically separated either by air or insulating material. The insulating material between plates is commonly called the dielectric. The amount of charge that can be stored in the capacitor depends on the size of the plate and the distance between these two plates. The larger the plate and the shorter the distance between the two plates, the greater will be its capacitance. The next one is the rectifier. Rectifier is an electrical device which converts an alternating current into a direct current by allowing the current to flow in only one direction. This is done by either suppressing the negative cycle of an alternating current or by converting it to a positive cycle. The process is called rectification. The output DC is a pulsating DC and not a smooth DC. To compare, here's the smooth DC, usually provided by a battery. And here is the pulsating DC as a product of rectification. As you can see, the voltage is still fluctuating from 0 to certain maximum value and back to 0 again. And this is the symbol for rectifier. Current will flow from this direction towards this direction where the arrow points. The device that is used for rectification is called a diode, which allows electron to flow in only one direction. Some type of rectification requires a series of diodes. The X-ray tube having a cathode and an anode or negative and positive side is also a diode because it only allows the flow of electron from cathode to the anode side. There are two types of rectification, the half-wave rectification and the full-wave rectification. Half-wave rectification uses one or two diodes. This will allow only half of the AC cycle to pass, while the other half is blocked. The resultant output voltage is similar to this. As you can see, there is a gap in the current flow for when the rectifier blocks it. On the other hand, full-wave rectification uses several diodes that allow both the positive and the negative cycle of the AC wave to pass. In this case, the negative half cycle is not blocked, but rather converted to positive cycle. The resultant voltage waveform looks like this, where there is no gap in the flow of current. However, as you can see from the waveform, the voltage is a pulsating one. Full-wave rectification is more desirable for X-ray machine. The next device is a rheostat. Rheostat is a kind of resistor, a variable resistor. It is an electrical instrument that is used to control current flowing in the circuit by varying the resistance. Compared with ordinary resistor, rheostat can vary the resistance in a circuit without interruption. Shown here are examples of rheostat, a rotating one and a sliding rheostat. And these are the symbols for rheostat. The last that we have to discuss are the protective devices. First is the circuit breaker. Circuit breaker is a device that opens a circuit as soon as the current climbs to unsafe levels. It is an important electrical component and we often see it in our houses. The basic circuit breaker consists of a simple switch connected to an electromagnet. When the switch is flipped to an on position, electricity can flow from one terminal through the electromagnet and out to the other terminal. The electricity magnetizes the electromagnet. When the current jumps to an unsafe level, the electromagnet will be strong enough to sever the contact point and shuts off the electricity. The next one is the electrical grounding. The grounding system is a backup pathway that provides an alternate route for electrical current to flow back into the ground in the case of a problem in the wiring system. In the electrical socket, the ground is represented by the circular receptacle on the bottom part. So this ends our presentation for today. Thank you very much.